Today, it's even more derivatives. Remember, the game is that we have some base derivatives. We've now expanded on our list of base derivatives with derivatives of inverse functions. We use the chain rule to generate some derivatives of inverse functions. That added natural log, arcsine, and arctangent to our list of base derivatives that we can use with our chain rule, product rule, and quotient rule in combination. There are two things that are going on here. So to step outside of just doing a bunch of problems, the things that you want to pay attention to are the base derivatives, which is a memory check. These are just things that you have to remember. This is just now added to the list of stuff that you need to remember as you go through math. This is just the calculus version of the times tables. This is just the calculus version of the unit circle from trigonometry. It's just a big list of more stuff that you just get to remember from now on in perfect detail. It only seems like a lot to remember because it's a lot to remember. And you have to remember all of it, all the time, in perfect detail. If that seems daunting, you don't need to worry about it. You remember things from a long time ago. You remember what happened in the MCU at certain points. You can remember this. I mean, it's a little bit unfair because everything that happened in the MCU was kind of the same thing over and over again, but you get the idea. That shit started in 2008. So the idea is that there's a list of things that you have to remember. There's another list of things that you have to remember, but the three rules, chain rule, product rule, quotient rule, that's also a reading exercise. This is where we have to be able to read how our functions have been combined. The point is that we learn how to read how the functions are combined. Not just because we need to be able to take derivatives of those functions. That's just the context under which we're learning and practicing to read how functions are combined. Almost never in math class is the thing that you're doing really the point of the thing that you're doing. There's always some kind of ulterior motive. This is why you're all suspicious of your math classes. The language is very precise, and that's very annoying because human language does not work that way. It's also very unsettling because there's always some kind of ulterior motive that you suspect is going on, but you don't know what it is. And sometimes the teacher doesn't even tell you. Like in trigonometry, back when you were doing all those trigonometric identities, making the left side look like the right side. The point of that was that not that those identities were going to be so important. That was an algebra exercise. It's like, oh, here, do this to practice learning your trig identities. But secretly, the ulterior motive is that we want you to be better at algebra, because algebra is the language that we use to communicate this stuff. Algebra is how numbers behave. So we need to speak that language fluently. That makes sense? It's not about this thing. A lot of times that happens and we don't tell students what's going on. Sometimes it's because they're children and they don't need to know. Sometimes they're adults like we have here, and we still don't tell you because we got into the habit of not telling you shit back when you were children. Messed up. We should update that. All right. With that in mind, I have some problems for reading exercise. This is called product, quotient, and chain rules. And I realize that I really prefer to say chain, product, and quotient, which is why I always stumble when I say product, quotient, chain. There's also the sound in product and the sound in rules that make it hard for me to say. So for this exercise, you're going to take a look at reading these reading these functions. Excuse me. Going to practice reading these functions. There are 6. I can't fit them all on one screen. Going to practice reading the functions and then apply the appropriate rules. So there are a couple of things going on here. Number 1, memory check. I've got combinations of 3x squared, cosine of 5x. I got cosine squared. I got an e to the 5x. So I only really have 3 different functions going on. I got a cosine, an e to the x, and I got a polynomial. We've got combinations of those three things. This is a reading exercise about how they are combined, and then it's a mechanical exercise implementing the rules for combinations of functions. Any questions? Comments? Snide remarks? I think we're going to start off as we're going to practice reading. And then we're going to break into here's what's coming down in this row. Put some spin on the page. I'll give this paper a credit scroll on the video. I should have some theme music for this. Okay, that's